So the electricity system, the thing there is that it needs to be always perfectly in balance. So the supply and the demand needs to be constantly the same. And the traditional way how we did this in our societies was by regulating the supply, so the production of electricity. So the supply always followed the demand. So it means when there's a lot of demand, in particular during the evening peak, then we just put on the power plants a little bit higher, and then the balance is restored. That's how it used to work. But now, with the introduction of renewables, things are changing, simply because you cannot control the sun and the wind. Just to get you a little bit an idea of how this looks like, this is a picture from Denmark for some typical days. I think it's 14 days, something like that. There you see the wind production at the bottom is the blue, and then you have the demand in red, and you see here a pattern because the demand is not always the same, of course. And now with what we present here is 20% wind power. You see that you still have a gap between the wind production and the demand. But if we go to higher levels of renewables in our energy supply, let's say for example 50%, and we already see that there are moments that we're producing more energy than we actually need. But there's always still moments where we don't even have enough power to cover all the demand. So this is a challenge when we're going to renewables. And you could maybe think, okay, let's put a lot of batteries in our electricity supply, so that we can charge the batteries the moment there is extra production, and then discharge the batteries when there's not so much production. But just to give you a little bit of feeling about what we're talking about here is consider the Tesla batteries that were installed in Australia. I think it was about 4 years ago, if I'm not mistaken. They hit the news with Elon Musk saying, I can give you a battery system in 100 days. He actually did it in 60 days. It was a great achievement of him. But it was a storage of 129 megawatt hours. By the way, cost 90 million, which is not cheap, I would say. But if we look at the daily uses of the Netherlands, we use 2,000 times that storage capacity. So we're talking about 0.04% of our daily energy consumption we can actually store in this huge battery, which by then was one of the biggest in the world. And it was already quite expensive. So the point is here, we don't get where we want to be with only batteries. We need something more. And another alternative is what we call demand response. So instead of the supply following the demand as it used to be traditionally, we could also think about, okay, what if we now change the moment we demand our electricity, if we make that more match the supply. And what you could think about is now, for example, charge our electric vehicles. We got one of the owners there in the back. At the moment, there's actually a lot of energy available, and because this car is not on the way most of the time, so the moment he is parked, there is a lot of time to say, okay, now there's a lot of wind or solar production. Let's use those moments to charge the car. That's one of the things. But another thing could be to use the white goods in your apartment, for example, to turn them on the moment there's a lot of energy available. And that's what we're talking about here. And that's actually what we're doing in this project called InterConnect. Because there is a challenge with this demand response of white goods. There's many brands out in the field. And you in your apartment already have Siemens and Miele, but of course there's other manufacturers as well. And they all have different solutions to be able to steer the devices, such that they turn on the moment there is a lot of renewables available. And in InterConnect, we are looking for interoperable solutions, such that we prevent vendor lock-ins, and that we create an open system in which energy flexibility, for example, of white goods can be used by all kinds of service providers that can do something with that energy flexibility. So this is the mission of the InterConnect project. We're working on technology for interoperability in an energy ecosystem. And we're doing that in different countries. So it's not only your apartment that's a part of the project. There's many other countries in Europe where this technology is also used and validated. And if we zoom into the Netherlands again, then apparently this is our country. I'm not from Eindhoven, so first I thought it's a map of Eindhoven, and then here is striped S. But then I looked, oh no, Eindhoven is actually pointed here. Oh, then it must be something different. And in the Dutch part of this InterConnect project, we have your next apartments, but also the apartment at the other side of the road. It's called the Video Lab, where there's 200 companies housed. We're also testing and validating our technologies there. Okay, that's about the InterConnect project. We go back to your white goods. Because like I said, it's possible, at least theoretically, to start the devices the moment there is sustainable energy available. And in particular, when we're talking about the dishwasher, the washing machine, and the dryer, and then the moment you filled up your dishwasher, that's not necessarily the moment you also want to have it finished after 2 hours, for example. So you can give the device more time between when you filled it and when you want to have it finished. And there is energy flexibility, how we call it, in between. And we in InterConnect are working on solutions to use that energy flexibility such that we can use more sustainable energy. Just to give you a little bit of an impression, numbers of course depend very much on individual cases, but I just took some averages, and we're talking here about approximately 1/3 of your energy consumption that goes into your white goods on average. So that's quite significant. So if you can move that to moments when there's more sustainable energy available, or to when the energy prices are lower, well, it's significant, I would say. But how would this work? Because we were talking about using sustainable energy for your white goods, and you also could, for example, then go on the internet and look at what is the CO2 intensity at this moment. You have this nice tool. It's called electricitymaps.com, if I'm not mistaken. My link was here, but I saw that it's dropped off the slide, so that's unfortunate. I can share that slide of that map. But what you can see here is at the current time, what is the amount of CO2 that is emissions for the production of electricity. So we see here, for example, that we're doing, well, kind of middle mode, particularly compared to Germany, which is very fossil intensive, but compared to the Nordic countries where there's a lot of hydropower, they have a little less CO2 emissions for the energy they're producing. So what you could do is look at this map and then think, okay, I like this color now. Now I'm going to turn on my device. But then you have to look at the map all the time. And that's not so nice, I would say, particularly at night when you want to sleep. So you could also ask InterConnect to do the work for you. And then I'm not personally going to look at the map all the time and then switch on your devices. No, we automated that in InterConnect. And let me see, this is how this works. So we got an onboarding process in which we help you connecting the devices if it's not already connected to the Wi-Fi. And we link the devices then to an energy management system. It's called Reflex. And Reflex is actually the system that looks at the energy prices, the day-ahead energy prices, and then selects the cheapest moment to start your device. And since, like Ronnie said, that's typically also the moment that the most sustainable energy is produced, we think that this is a sustainable choice. But you do have to use the delayed start because you do need to communicate somehow to the Reflex system when you finally want your program to be finished. So the delayed start, simply means, okay, I want this program for somewhere to start between now and 4 or 6 or 8 hours from now, just depending on your preference when you want to be it finished. And then Reflex uses the moment as a lot of energy, renewable energy production. So, to conclude, these 2 important notes, you will get help to connect your devices, and every time you start your device, you have the possibility to say, okay, I'm going to use the delayed start or not. But if you do, then you give the possibility to Reflex to start your washing program the moment the most sustainable energy is available. And that concludes my presentation.